Hi everyone, welcome back. In this lesson, we're going to tackle a challenging problem that takes your SUVAT problem solving to the next level. This is an algebra problem and involves two objects moving under acceleration at the same time. I know algebra can feel tricky, but don't worry, we'll walk through it step by step. We'll also apply a technique we've used before, defining the positive direction. In this problem, you'll see exactly why that matters so much when dealing with vectors. Before we dive in, take a moment to pause the video, then we'll solve it together. Alright, let's interpret the question together. At first glance, you can see the question involves two balls, which means we'll be dealing with two sets of SUVAT quantities. Don't be scared. You'll soon see that these two sets share some common quantities. First, I have defined upwards as a positive direction. Then, let's highlight key information. Ball 1 is dropped from rest, so its initial velocity u1 is 0 meter per second. Then the question asks, at what time are both balls at the same distance above the ground? Look at the graph. This point is where the two balls have the same height, and it happens at the same time for both balls. So, same time t for both sets of SUVAT. And it also implies that the two balls are moving vertically, and the air resistance is not mentioned. So they have the same acceleration of free fall. Now for the most important part. What does same distance above the ground really means? Does it mean the two balls traveled the same displacement? Pause and think about that for a second. Alright, the answer is no. The displacements of the two balls are different. Let me draw something on the graph. Ball 1's displacement, S1, is from height h downwards, so it's negative. Ball 2's displacement, S2, is from the ground upwards, so it's positive. If we add S2 to the reverse of S1, these two vectors will add up to the height h. And this leads us to the relationship S2 plus the negative S1 equals to h. If that's not quite clicking yet, that's okay. Drop a comment below and I'll walk you through it in more details. Let's move on to build the logic chain. We will start with two sets of SUVAT. Search for the SUVAT quantities from the question. Substitute these into the equation and find the expressions for S1 and S2. Next, we will need to substitute S1 and S2 into this relationship. S2 plus the negative S1 equals to h. Then we can solve for t. If you would like to try the algebra yourself before we do it together, pause here and give it a shot. Let's walk through the solution together. Let's figure out the S1 expression for ball 1 first. We have S1, U1, we don't have V, we have A, and T. This is our expression for S1, and we can further simplify it. Because we know from the question, the initial velocity of ball 1 is 0, so U1 is actually 0. And this leads us to S1 equals to half AT squared. Then let's do both too. We have S2, U2, which is actually U. We don't have V either. We have A and T. And this is the expression for S2. Next, we need to substitute S1 and S2 into this relationship. And we get these two terms cancel out. And we rearrange the equation, and we get the final answer, t equals to h over u. Alright, let's have a quick recap. I'm sure you've understood the importance of defining the positive direction. Also, remember to draw vectors on your diagram so you're not misled by the wording of the question. Before you go, I'd love to hear what you thought. Was the pace comfortable? Anything still unclear? Please let me know in the comments. I'll read every comment and adjust my content for you. Thank you, and I'll see you in the next video.